Right now, on the big island of Hawaii, scientists are watching a volcano move faster than it has in months, and the speed of that escalation is exactly what has researchers on edge. This isn't a slow simmer anyone can shrug off. Within the span of about 24 hours, Kilauea went from quiet monitoring status to full lava fountaining, and the jump happened so fast that even people who track this volcano for a living are calling it one of the sharpest alert escalations they've seen in this entire eruption cycle. Here's exactly how it unfolded. On the morning of August 12th, 2026, the U.S. Geological Survey's Hawaiian Volcano Observatory recorded low-level eruptive activity beginning inside Halemaʻumaʻu crater, intermittent lava, fountains and overflows starting around 11:20 in the morning. Almost immediately, officials elevated the volcano alert level from advisory to watch and bumped the aviation color code from yellow to orange. That might sound like routine bureaucratic language, but it's not. Advisory means a volcano is simply showing signs of unrest above its normal background levels. Watch means an eruption is either underway or expected imminently, with the potential for hazards extending beyond the immediate summit area. By the afternoon of that same day, the precursory activity had fully evolved. Episode 53 of the ongoing Halemaʻumaʻu eruption officially began at 3:45 p.m. Hawaii time, with fountaining erupting from the north vent. Within about 2 hours, fountain heights had already climbed to 500 feet. For comparison, that's taller than most skyscrapers in a major American city, and it happened from a single vent inside one crater, visible from miles away. Now here's where this story becomes genuinely important, not just dramatic. Kilauea has been erupting in this exact pattern since December 23rd, 2024, and episode 53 is now the 53rd time this specific cycle has repeated. Scientists studying the pattern describe it as one of the most unusual and best documented eruption sequences ever recorded at this volcano. Instead of one long, sustained eruption, Kilauea has been producing short, violent bursts of fountaining, almost always lasting less than 12 hours, followed by pauses that can stretch anywhere from a single day to more than 3 weeks before the cycle repeats itself. That pattern alone has already made history. Back in June of this year, this eruption sequence officially surpassed the previous record holder, an eruption known as Pu'u, which produced 47 episodes over its lifetime. Kilauea's current cycle blew past that number and kept going, all the way to 53 episodes and counting, making it now the most episodic fountaining eruption ever recorded at this volcano. But recorded history isn't what should concern you here. It's the rhythm of the gaps between eruptions, because that rhythm is exactly what scientists use to try to predict what's coming next, and right now that rhythm has been tightening. Looking at the spacing between the most recent episodes tells the story clearly. 14 days. Separated episode 44 from 45. Then 12 days between 45 and 46. Then just 9 days between 46 and 47. The pattern isn't perfectly linear. It stretches back out sometimes. 18 days here, 13 days there. But the overall trend scientists have been documenting is a volcano that keeps refilling its underground magma reservoir fast enough to trigger episode after episode, month after month, without any sign of the deep system running low. And this latest cycle leading into episode 53 moved unusually fast. Officials initially forecast a window between August 7th and August 14th. Then, as new tilt data came in from instruments monitoring ground deformation at the summit, that forecast window shifted, first to August 11th through 14th, then again to August 13th through 17th. Scientists watched the ground itself rise and fall in real time, tracking inflation and deflation cycles that typically last 2 to 3 days before each new episode, and use those tiny shifts measured in microradians, fractions of a degree in the tilt of solid rock, to estimate, almost to the day when lava would break the surface again. And then, faster than even that adjusted forecast suggested, the mountain moved. Precursory activity began the morning of August 12th, and by that afternoon, full fountaining had already started, just 2 weeks after the previous episode ended. 2 weeks. That's the number worth sitting with. Episode 52 happened on July 28th and 29th. Episode 53 arrived less than 15 days later. Compare that to some of the longer pauses earlier in this eruption, stretches of nearly 3 weeks or more between events, and you start to see why scientists are calling this particular escalation unusually fast. The volcano isn't just continuing its pattern, it's cycling through that pattern more quickly than it has in recent months, refilling and erupting again almost back to back by Kilauea's own historical standards for this eruption. So what does that actually mean for people living on the Big Island or anyone watching from afar? The most immediate hazard isn't lava reaching neighborhoods because all of the eruptive activity remains confined within Halemaʻumaʻu crater, inside Hawaii Volcanoes National Park. The real hazard, the one that reaches far beyond the crater rim, is gas. Even while the volcano sits paused between fountaining episodes, the summit continues releasing an estimated 1,000 to 5,000 tons of sulfur dioxide every single day. That gas reacts with the atmosphere to create VOG, volcanic smog that drifts downwind and can seriously affect air quality across entire regions of the island. Health officials specifically warn that people downwind with asthma or other respiratory conditions, older adults, young children, and pregnant individuals face the greatest risk from these ongoing emissions, disaster or not. There's also tephra to consider, the volcanic ash, glass fragments, and strands of volcanic glass known as Pele's hair that get carried by wind depending on which direction it's blowing during each fountaining event. During episode 53, officials specifically warned that low-level winds could push material toward communities southwest of the summit, while higher altitude winds could carry finer ash toward areas closer to the national park itself. This is an abstract risk. Roads have closed. Overlooks inside the park have shut down. Civil defense officials have issued specific guidance for anyone living downwind, including advice to disconnect water catchment systems that could otherwise collect ash and volcanic contaminants directly into a household's drinking water supply. Here's what makes this moment particularly worth paying attention to. Beyond just another eruption update, this escalation isn't happening in isolation. At the exact same time, episode 53 was ramping up. Meteorologists were separately tracking a developing tropical disturbance southeast of the Big Island, one being monitored for potential development into a tropical cyclone that could affect the state of Hawaii within days. Two entirely different natural hazards, a volcanic eruption accelerating faster than its recent pattern and a possible tropical cyclone approaching from the ocean, both demanding attention from the same emergency management systems, the same civil defense agency, and the same residents during the exact same week. That kind of overlap is exactly why scientists describe this specific escalation as not reassuring, even though, technically, nothing about episode 53 breaks entirely new ground for this eruption sequence. It's not the fountain height that has researchers concerned. 500 feet is actually well below the more than 950 feet recorded during episode 51, and far short of the over 1,000-foot fountains seen earlier in this cycle. It's the speed of the buildup, the tightening rhythm between episodes, and the fact that this volcanic escalation arrived at the exact same moment as a separate, unrelated weather threat, stretching the island's monitoring and response capacity across two different disaster types simultaneously. Scientists studying this eruption have been honest that they still don't fully understand what's driving the underlying rhythm. The stress building in the rock surrounding Kilauea's magma system could sustain the current pattern indefinitely, shift toward even shorter pauses between episodes, or eventually transition into something different entirely, potentially a sustained lava lake rather than these repeated short bursts. None of those deeper mechanics can be observed directly. Researchers infer them from tilt meters, seismic tremor data, and gas emission readings, essentially reading a mountain's pulse from the outside and trying to predict what's happening deep beneath the surface based on tiny surface signals most people would never notice. What we do know is this. Kilauea has now produced 53 episodes of fountaining in under 2 years. A pattern with no clear historical precedent at this volcano, cycling faster into this latest episode than it has in recent months, arriving right alongside a separate developing tropical threat, and continuing to pump out volcanic gas that affects air quality across the island. Regardless of whether fountains are actively visible, scientists aren't calling this a crisis, but they are calling the speed of this particular escalation something worth watching closely, because a pattern that's been reliable for 2 years just moved noticeably faster than it has in a long time. And nobody currently monitoring this mountain claims to fully understand why. It's worth understanding just how much this eruption has already reshaped daily life for people living near the summit, because the disruption isn't limited to the hours when lava is actually visible. Hawaii volcanoes. National Park has had to repeatedly close roads, overlooks, and trails throughout this entire cycle, sometimes with very little notice, since the exact timing of each new episode still can't be pinned down with certainty, until the ground itself starts signaling that fountaining is imminent. Visitors hoping to see an episode in person are essentially chasing a moving target. One park officials themselves describe as a probability window rather than a scheduled event. Tour operators, hotels, and local businesses built around volcano tourism have had to adapt to that same uncertainty, planning around forecast ranges that can span several days and then still shift again as new tilt readings come in. For residents, the disruption runs deeper than tourism logistics. Communities downwind of the summit have had to learn to live with recurring air quality warnings that can arrive with almost no lead time, since wind direction, not the eruption itself, determines who actually breathes the volcanic haze on any given day. Some households have installed air purification systems specifically because of this recurring VOG exposure. Farmers growing crops downwind have reported dealing with acidic rainfall linked to the ongoing sulfur dioxide emissions, which can damage sensitive plants and affect water collected for irrigation. None of this makes headlines the way a 500-foot lava fountain does, but for the people actually living through this 2-year cycle, it's the quieter, grinding reality of an eruption that simply refuses to end. There's also a broader scientific significance to what's happening here that reaches well beyond Hawaii. Volcanologists around the world study episodic eruptions like this one because they offer an unusually detailed window into how magma systems behave over long periods of sustained activity. Most eruptions are studied in isolation, a single event with a beginning and an end. Kilauea's current cycle is instead offering scientists 53 separate data points from the same underlying system, each one slightly different in fountain height, duration, and the gap that preceded it, creating one of the richest real-time data sets on episodic volcanism ever assembled. Researchers are using that data to refine forecasting models that could eventually help predict eruption timing at other volcanoes around the world that show similar episodic behavior, even ones that haven't erupted in decades and have far less monitoring infrastructure in place than Kilauea currently does. That's part of why this latest acceleration matters so much to the scientific community specifically. If the tightening gap between recent episodes turns out to be the start of a genuine shift in the volcano's underlying rhythm, rather than just normal variation, within an already unpredictable pattern, it could signal a fundamental change in how magma is moving through the system deep underground. That kind of shift, catching a major transition in real time as it's actually happening, is exactly the kind of moment researchers spend entire careers hoping to observe and understand. If this kept you glued to the screen, do us a favor and like this video and subscribe, because we're going to keep tracking Kīlauea and every other natural threat quietly escalating faster than the headlines are catching up to. The mountain isn't finished. Episode 54 is already next.